Hello, everyone. Let's start this camera. Okay. Oh my God, look at the chat. Rosen, Lamis. Hello. Yes, Dalia, we will send the recording. Hello. Farida Shmes, Omar Tamer. Oh my God. My voice is low. 1 second. Yes, before I start, I want to make sure that you guys can hear me very well and can see me. You guys can see me on the camera? Hellos, hellos. Yes. Okay. Can you hear me well? Can you hear me well? Yeah? Okay. So the mic is good. I mean, it should be a good mic. So yeah, it's perfect. All right, wonderful, wonderful. So good to see you all. Of course, most of you were my students last year. New students, welcome. How are you? How's it going? Hope all is well. Let me share this screen. Now, you guys know my style. I want your participation. Before I start, I also want to let you know that we have some amazing four panelists or like co-hosts who are also here in this oh Lemise, oh my God, look at you, who are here on this meeting. And so and those are Miss Dina. Miss Dina is here if you have any administrative questions, if you want my phone number, like if you need anything, she's here. Miss Saba is also here. She's got all the information about this course. And she is the one who did this 30-minute countdown video. Did you guys like it? It is amazing. Way better than the one I made last year. You guys remember mine last year? So, and she tricked you. So, I love that part. I think it was nice. Yeah, yeah. All right, so Miss Saba is also here. So Miss Dina is here. Miss Saba is here. Also, Miss Omniyat is here. Miss Omniyat is an amazing, amazing chemistry assistant. She used to be my student years ago. She was a high achiever. She got a really good grade. She also finished her A levels and she's ready to go to medical school. Or maybe she changed her mind. I don't think she changed, but anyhow, she is here. She will answer any chemistry questions you have if you have any. Yesterday I did this class for the Cambridge students. It went really well. We had 15 participants. They did amazing. And yeah, I think they understood everything. And we also have a Kahoot. All right, so at the end of the session we will have a Kahoot, so make sure you are prepared for that and let's see how you do. Yesterday students could answer the Kahoot in like 5 seconds. I was like, oh my God, how did you even, like, did you read the question? All right, and we also have a new team member. Her name is Rabia. Now, what Rabia is going to do is she's going to watch your participation. So it's not just me. I am looking at your participation. I'm reading your text. I'm looking at what you do. But she's going to have an eye on the Zoom and she's just going to be like, what are they doing here? So yeah, I'm really excited about this year because we have some really good follow-up and really good control over things. I miss you too. Yeah, eagle eye. I miss you too so much, guys. Thank you so much for all of you for being here on time, for joining on time. I think you guys started joining like 40 minutes before the session. Whoa. Yes, that was amazing. So let's get started. So the first session or the first lesson in the AS. Now, did you guys get a chance to watch the 9-minute video I sent on the group? In that 9-minute video, oh, Meta Phillips is here. In that 9-minute video, I explain exactly how the AS Edexcel goes, how what are the papers you take and at what time, and because we're going to be done with unit 1 before January, and then we're going to do units 2 and 3 by May. And guys, I just want to tell you, unit 1 is very easy to get a full mark in. You can get a full 120 out of 120 in paper 1. Very easy. Well, the raw mark is 80 marks. Very, very easy to get the full mark. Okay. So that's paper 1 or unit 1. Unit 2 and 3, it's not as easy to get the full mark, but still some students get the full mark. Okay, so January will be unit 1. And June will be units 2 and 3. Super easy. You just follow my steps, just like last year, guys. You just follow my steps. You do my homework. The only difference in AS is you've got to be much faster, way faster. And so you're going to do the homework like 3, 4 times. Like repetition is important. Practicing a lot is important. Doing the past papers 2, 3 times is very, very important because there's not many past papers like last year. O-level Cambridge, we had, I don't know, like 100 past papers, right? So it was like there was plenty of practice, but AS there's not as many past papers because it only started, I think, 2012 or something. But you cannot go back way too much. Like you can only go back to 2019 because before 2019 the syllabus was different. So Dua Fatima Unit 1 is the easiest. Unit 2 is just slightly, like teeny weeny harder, okay? But not really much. I think you're gonna still enjoy it a lot. Unit 3, if you guys took the O-level Cambridge, paper 6 was alternative to practice. Unit 3 is the same thing. It's that alternative to practice, okay? All right. Compared to O-level, how much? So whatever, like in the O-level, you worked hard, you did my homework, you were diligent. You're going to do the same thing this year, right? You're going to be diligent, you're going to work hard. But what's really important this year is repeating a lot, solving the questions many, many, many times, okay? All right, let's get started. So today's session is going to be about the atomic structure, which, by the way, you will find that, I don't know, like 50% of today's session is kind of not new. And then we have some small new things. But, oh yes, like getting a full mark in AS Edexcel should be a piece of cake if you follow my strategy, guys, please, okay? Oh, Ammar, no, your cameras and microphones are not on. However, guys, do not worry. In the Is this session related to AS? Of course, it is an AS session. It is an AS chemistry session. This is not O-level, right? So, Ammar and someone else, I think, asked about cameras and mics. We will have cameras and mics in office hours, okay? So, Umniyat is one of our team members who is going to offer office hours. We have 4 office hours a week. So, you can join one of them. You just choose one of them. And that's where you will have your camera, your mic, and Miss Rabia will report and will say if your camera was on, if you were participating on the mic, if you're answering questions. And so please, yes, please open your camera and mic in those office hours. But here in this main session, because I really do not want any distraction, if you guys want to open the camera, your mic, please let me know. Just raise your hand. No problem at all. You guys know my style. I do not end my Zoom session until everybody's happy, everybody's satisfied, everybody understands everything, right? Okay, so let's get started. Before I start my first slide, I just want to remind you that chemistry, it is absolute happiness. And the classes are fun. So guys, just relax and pick your best couch in the house, go sit in the most comfortable place, kick out your brother and say, hey, I'm doing chemistry, so I need to be comfortable, need to be relaxed because I'm gonna have fun and I'm gonna enjoy. All right, so today's topics is, actually, there's a 4th topic here. So we're going to talk about atomic structure. We're going to talk about isotopes. There's going to be a little bit of a new thing here today, something called spectrometer or mass spectrometry. And then we will also solve some past paper questions. Because I want you guys to see how questions appear on the exam and how they look like. All right. Dua Fatima attended yesterday's session, which was Cambridge, and so she saw how Cambridge's questions come. Today, she's going to see how Edexcel questions come. And she is one of the few people who can actually compare the 2 boards because I think she's like trying to pick. Guys, it doesn't matter what you do. Cambridge Edexcel really doesn't matter. You have to work hard anyhow. Okay. All right. So let's start with the atomic structure, something we learned before. So the atom, like, let me get a piece of paper here, okay? So this really small piece of paper that I cut off my like, look at how small this is. Can you guys see how small this is? Yeah, I mean, can I cut it even smaller? Can I cut it smaller? Hello, Saifuddin. Oh my God, I miss you so much. Are you Saifuddin Khalid? Because I love Saifuddin Khalid. I don't know if it's oh, it's you. Oh, it is him. All right, I cut my paper even further and further and further. Okay, I think that's the smallest I can get. Okay, how many particles are here? A lot, right? Not 100, not 1,000, not 1,000,000. Like what? Several millions, because 1 mole, right, is 6 times 10 to the power of 23. 23 zeros! We're not talking even billions, like that's gazillions, right? And these, like the smallest unit, you guys know, is called an atom. And the atom kind of look like this. Guys, does anyone know which atom is this? I drew a specific atom. This is not random. Anyone? 32 participants. Can anyone tell me what this atom is? No one? Ah, Saifuddin, you got it. Yes, that's right. Ahmed. Judy, that's right. Rines, that's right. Fatima, that's right. Lamis, Lujain, Abdurrahman Shaheen, Mena Phillips. Anyone else? That's it? 12 students? That's the question. What's this atom? What is this atom? Rosen, no, it's not nitrogen, Rosen. Which atom is this specifically? Nisreen, that's right. Although you have to make it an uppercase. Omar Tamer, that's right. Yes, this is recorded, Janaisa. All right. So actually, this is lithium. How did people know it's lithium? The 14 students who answered, how did they know this is lithium? How did they know this is lithium? Fatima Zahra is asking, are there pre-recorded videos for this course? There are classified videos for all the sessions, Fatima Zahra. Classified videos for all the sessions, okay? Now, pre-recorded videos, I'm still working on it. Still working, so no promises. I'm going to say just consider the answer to be no, okay? Because it's not done yet. So there's classified videos that I've recorded before for each lesson, all right? Sounds good, Fatima? Fatima Zahra? Are you Fatima Zahra, my last year students? You are, right? Okay, I love you. Oh my God. Okay. Yes, that is. Okay. So yes, you are right, Fairuz. Thank you very much. You guys all knew this is lithium because it had 3 protons. Although I did not even put the pluses here. So, but you could figure out from the electronic configuration, 2 in the first shell, 1 in the second shell. So this is actually lithium. But anyhow, how are things arranged in the atom? Because years ago, scientists just thought that the atom is just one particle, but then they found out there are subparticles, and these subparticles are some of them, many of them, the heavy stuff is in the nucleus. Nucleus means the heaviest part. Just like in your biology, right? In your biology, you took that there's this heavy thing in the center of the cell, and then there's stuff around the cell like mitochondria and a lot of water and a lot of ions, and there's a cell membrane, blah, 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 right? Okay, so kind of similar to, not really similar to biology, but yeah. And then there's stuff that's revolving and moving quickly at very high speed around the nucleus. All right, so there's something outside the nucleus, and they are arranged in energy shells. Now, these subparticles, there are 3 kinds of subparticles that we studied last year, and they are different from each other. And how are they different? So the first difference is in the charge. Can you guys type on the chat, what is the charge of protons, charge of neutrons, charge of electrons in one message? Charge of protons, comma, charge of neutrons, comma, charge of electrons. Thank you, Lamis. Thank you, Fatima. But Fatima, what is the charge? Yes. Thank you, Dua. Lamis, thank you. Yes, that's correct. Dua. And the other Dua, there's 2 Dua. Dua Ahmed, Dua Fatima. Lujain, you're talking about the mass. Delia, thank you. Yes, that's the charge. Nisreen, yes, that's right. Leen Yunus. Oh, Yunus is here. Okay. Mayar, that's right. Mena Phillips, that's right. Ammar, correct. Fairuz. Oh, Fairuz, you're here. Farida. Fatima, Rines, Judy, Adam. Adam Nakhla, how are you? Oh my God, I miss you. And Maryam Mohsen, that's correct. Anas, how are you? Yes, that's correct, guys. So, yes, protons are positive. This is not new information. Neutrons, from the name, are neutral. And electrons are negatively charged. And because protons and electrons are opposite in charge, what do? When you have something that's opposite in charge, something we took in our grade 2, in our second grade, what do opposite charges do? Exactly. Thank you, Razan, Noon, Ammar, Nisreen, Juri, Saifuddin, Lamis, thank you. Okay, yes, they cancel out each other, but they do something else. That's a good answer. Yes, they do cancel out each other. Lujain, Anas. All right, good. Jannah, you're not participating. Lamar, was your answer? Yes, they attract each other. If they have opposite charges, they attract each other. And if something is similar in charge, so positive and positive, they repel each other. Okay. And also someone said, I cannot remember who, Delia said, they cancel out each other. So if you have 3 positive and 3 negative, boom, your atom is overall neutral, doesn't have a charge, right? This whole atom, this lithium atom, does not have an overall charge. Why? Because we have 3 positives and we have 3 negatives. So excellent job, Delia. Yes, they do cancel each other. Okay. All right. The second feature is mass. Now there's a big problem with mass. I just showed you a piece of paper that has millions and millions and millions and millions and millions of atoms. Can you possibly get the mass of one atom? That's very, very difficult. You need a balance that's super duper sensitive, right? So that is not possible. With the technology we have, very hard. Okay. And so the mass, scientists said, okay, let's just call it a unit. We cannot give it grams or milligrams or nanograms or any of that stuff. We're going to just call it 1 unit. So we're going to give the protons 1 unit. The neutrons are also 1 unit. The reality is they're not equal, but that's not in your syllabus. You don't have to know about that. But they're almost equal. So protons are 1 unit. Neutrons are 1 unit. Electrons, however, oh my goodness. It's very, 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 very light. No comparison. I mean, protons and neutrons are kind of equal in size, equal in mass. But electrons, sorry guys, I restarted my iPad. And so it's kind of like not doing the font I like. And those of you who don't know me, I'm pretty picky with font, with size, with colors. Like it's, anyways, I'm too picky. But yes, the mass of the electron, you need almost 2,000 electrons to make it the mass of 1 proton or 1 neutron. It is so light. It is so, we call it negligible. Negligible means ignored, almost zero. Doesn't have, yeah, that's why, yeah, exactly, negligible, exactly, Luigi. The third thing is the purpose. We did not really talk about the purpose last year, but some of you will be able to tell me what the purpose of protons are. Can anyone tell me what is the purpose of protons? What are they doing exactly in the atom? What are the protons doing exactly in the atom? Okay, they give the identity. They are the atomic number to recognize the atom. That's good. To make up the atom identity. Thank you, yes. Because the atom depends on it. That's a good one. Attracts what, Omar Tamer? Attracts neutrons. Neutrons do not have a charge. They cannot attract neutrons. But you're almost there. Yes, you're almost there, Omar. Anas, excellent. That's what I'm looking for. Razan, yes. Mena Phillips, yes. Ammar, almost there. Lujane, yes. Lujane, I need to know how you pronounce your name. Is it Lujane or Lujine or like how do you pronounce it? I need like at one point in the lesson, please open your mic and tell me, okay? Um Maryam Mohsen, yes. To determine the atomic number, so we identify the element. That's correct. Make the atom neutral by canceling electrons. I mean, why is that important? Attract electrons to be yes, Farida Shimis, that's correct. Attract electrons. Yes, Laura, that's correct. Okay, so you guys provided. Okay, you guys did. Yes, the first one, Lujain. Lujain. Okay, thank you, Lujain. I pronounce it right, right? Okay. Because last year, oh my God, for months, I was pronouncing someone's name incorrectly. And she was okay. She said, oh yeah, my teachers in school do the same thing. But I was like, no, not doing this mistake again. All right, so what protons do is they are like your mom in the house. They're attracting everybody. They're keeping everybody under control. You know, like how moms are keeping everyone under control. So that's what protons are doing. They're in the center of the atom and they're attracting all the electrons and making sure they are staying here in the atom. Because if there's no protons, the electrons are going to be just flying everywhere. Nobody's controlling them. So this is like your control thing, your mom, your boss, sitting in the center, being overprotective and attracting everyone into the center, okay? Now, what about electrons? What about I'm going to get back to neutrons in a minute. But what about electrons? What are electrons doing exactly? What is the purpose? Like, why do you think there's electrons in the atom? What do they do? Produce nuclear power, like if you're gonna get into nuclear power, but in chemistry, like general chemistry. Lamis, that's correct. Fatima Zahra, excellent. Both correct answers. So far, 2 correct answers. Electricity is an example. Yep. Razan, you're too into physics now. Did you just have a physics exam? Yeah. Okay. All right, what else? What else? Give me more. Where's everyone else? Where's Judy? Where's Lamar? Where's Omar Tamer? Where's Anas? Where's Ammar? Where's Adam? Conduct current, yes. And yeah, give atom its chemical. Rines, excellent. Excellent. Anyone else? Just the 5 students, guys, come on. Jannah, where are you? And Jenna, Sarah, Selma, Saifuddin, where are your answers? Yahya, Fairuz, where are you? Nuruddin, no clue. Okay, okay. So you guys remember last year when we said that the atoms do not stay as atoms, right? They don't just sit and chill. I'm a neutral atom. I'm happy with them. No. They don't do that. They're ambitious. They're just like us people. They move and work and do stuff. What stuff do? They try to be stable. They try to have a full outermost shell of electrons. And so they lose electrons or they gain electrons. And so that's the purpose of electrons. They get lost or gained. If they get lost or gained, we call that a chemical. A chemical? Anyone? No one? Yes, Fatima, exactly. We call them a chemical reaction, right? And so atoms do these exchanges, do these things by losing or gaining electrons, and they undergo chemical reactions. So electrons, the purpose of electrons is to get involved in chemical reactions. Okay? Easy so far? All right. Thank you, Lujain. And thank you, Maria Mohsen. Maria Mohsen, your name is similar to Maria Mohsen. Who's in the O level, not in this course, yeah. But anyhow, all right. So I was gonna, yeah, okay, Razan. Neutrons. Now let's go to the neutrons because last year I did not tell you what neutrons do. I did not want to confuse anyone. What do you think neutrons do? They give a mass to the atom. That's correct. Yeah, what else? So look at this. Look at this atom. Look at this atom. All right. Look at this atom. Imagine if there were no neutrons. The neutrons are the yellow ones. Just imagine if these are not here. Imagine if I only had the protons, okay? Imagine if I only had the protons. I'm going to remove all those neutrons. Imagine if I just had the protons in lithium, 3 protons in the center. What do you think is going to happen? Similar charges. Yeah, it's going to be lighter, but they're similar charges. All of them are positive. Farida Shmay is correct. Dua correct. Farida Mayra Maryam correct. Jannah correct. Yes. Finally, Jannah participated. Rines, yes. Dalia, yes. Adam, yes. Excellent, guys. Excellent, guys. Mena Phillips, yes. They're going to repel each other, right? They're similar charges. They're going to be... like, yeah, they're not going to stay together at all, right? Because they are similar charges. And so, fortunately, God created these neutrons that have no charge whatsoever. And they're sitting in the nucleus to make sure protons do not fight with each other. All right? I mean, for example, I have 2 sons, 1 daughter. My 2 sons, they fight with each other all the time. But my daughter comes in and she stabilizes everything. So she's like the neutron who's preventing people from repelling and fighting each other. So that's exactly the purpose of neutrons, is to minimize the repulsion in the nucleus and stabilize the atom. Okay, stabilize the atom or stabilize the nucleus. Now, scientists discovered, and right now, so far, 118 elements. All right. About 200 years ago, we still had a lot of elements, like over 100 elements, a lot of elements. And scientists were like, okay, that's a lot of elements. Let's put them in a circle or in a table or in something. Let's arrange them somehow. And they kept trying things, a lot of things. I mean, if you read research papers, you will find a lot of things that they have tried. And then finally, Mendeleev came in and he said, I'm going to arrange it in a way, in actually a very smart way. Basically, each group has the same properties and same chemical reactions. And so it was a really smart way. And then so the most updated periodic table that we have right now, and it's been here for a decade, maybe, or more, not a decade, like 100 years, a century or more. The current periodic table has all the elements, and each element has 4 pieces of information. 4 pieces of information. It has a big number and a small number. They could be flipped. Sometimes the big number is up, sometimes the big number is down. Does not matter, guys. Does not matter, right? Because guess what? The periodic table will be given to you on the exam. So you're responsible for the periodic table you have on the exam. Yes, you can cheat from the periodic table you have on the exam, okay? So that's a nice thing. So they have 4 pieces of information, a small number, a big number. They also have the name of the element. So for example, this element is called lithium. And they also have this, what is this Li? What is this Li? What do we call it? So this is the name. What is Li? That's the symbol, exactly. That's kind of like the nickname. Who has nickname at house in their family? Who has nickname? Yeah, Rines, you do. Ranuna, maybe. Farida. Yeah, okay. Nice, nice, nice. Okay. Mimi, yeah, okay. So Zuzi, oh, that's a good one. That's a really, yeah. So I also have a nickname. So everybody, almost everyone. I mean, we couldn't give my son Adam a nickname. The others have. So yeah, that's a good one. So each element has a nickname. Not a nickname, a symbol, which is usually either 1 letter or 2 letters. So for example, lithium is 2 letters. And then there are 2 other pieces of information. There's a smaller number. What is the smaller number? Can you guys tell me what the smaller number is? Luli? Oh, that's very cute, Lujain. Yes, the smaller number is called the atomic number. Why do we call it the atomic number? Now, it's actually the number of protons, but why do we call it the atomic number? Why do we call it the atomic number? Atomic number. It's not the mass, Adam. It's the atomic number. Just the protons. Aha, Lamis. Because it gives the identity of the atom. It tells you what this atom is exactly. And what was the metaphor? What was the example I gave last year? Does anyone remember? I'm gonna give you a hint. This. Anyone remember? Ah, 3 people remember. Good. It's the fingerprint of your element. It is the fingerprint of your element. All right, it identifies your element. If it's 3 protons, then it's lithium, okay? And that's how like 6 students could tell that this is lithium. How? From the proton number. They were like, there's 3 electrons and there's 3 protons. This must be lithium, right? It wasn't the neutron number that identified lithium, and it's not the electron number. It is actually the proton number, okay? All right, there's a big number, which is 7. What is that big number? What does the big number represent? Mass number, thank you. The atomic mass or the mass number, which is equal to what? This is the mass of the atom, right? Do electrons have a mass? It's negligible. It's almost 0. It's like nothing. Blah, blah, blah. Not contributing to the mass whatsoever. What's contributing to the mass? The protons and the neutrons in the nucleus, right? So whatever is in the nucleus, that's what's contributing to the mass. And so this is the 4th piece of information, which is the big number, which is the protons and the neutrons, which have another name. It has another name, which is nucleon number. Thank you, Lamis. Excellent, Nisreen. Nucleon number. We also call it relative atomic mass. Why do we call it relative? We call it relative because this is not something, this is not a mass we found by placing the atom on a balance and actually measuring the grams. It's called relative because we're just comparing lithium to hydrogen, for example. So lithium is 7 times heavy as hydrogen, for example. Magnesium is twice as heavy as carbon. Carbon is 12, magnesium is 24. So we're comparing, thank you, Jenna, exactly. We're comparing specifically to carbon 12, thank you, Jenna. That's amazing. So yes, we're comparing the atoms with each other. We do not place any atoms on any balances because that's really hard and impossible. All right, with all this amazing, useful information that's in the periodic table, we can calculate or deduce one more piece of information. What do you think we can calculate from this, or what else can we find from this information? We can find 2 more things, actually. Excellent, Ahmed Hatem. Oh, Ahmed Hatem, you joined! Look at you! Did you join late? Okay. Excellent, Omar Tamer. Saif Eddin. Noon. All right, we can, so the question again is, are you zoning out? She asked me to repeat the question. Guys, no zoning out in Nervana's class. Okay? All right, good. All right, so there's 2 more pieces of information. The first one is, if we have 3 protons, then we also have 3 electrons if it's a neutral atom. Now, we do know that atoms do not just stay as atoms. They're gonna go and find a way to be stable and be happy, right? Okay. The other piece of it, I'd rather, if writing and typing distracts you, I'd rather have you focus, okay? Oh, Ahmed Hatem. Did the meeting require a passcode? Because I'm pretty sure. Oh, no. Ms. Dina, please make sure that meetings do not require passcodes. That's horrible. Ms. Dina, please make sure no meeting requires passcode. That's like, oh. Okay, anyhow, yeah, everybody said it required the passcode. Ugh. Okay, so this big number, from this big number, I mean, guys, remember, this big number is protons and neutrons. The small numbers is protons only. Again, the big number is protons and neutrons. The small number is protons only. Wink, wink. What do you think you can get? You can subtract and get neutrons only by doing the big number minus the small number, right? Okay. Now, like I said, Mendeleev, that's the smart guy who came and arranged everything in the periodic table. And not just arranged it in order of proton number. I mean, they first tried to put it in order of mass number, and that didn't work very well. And then he ordered it in order of mass of atomic number. And then not just that, he put it in a table where you have groups, not groups. Let me show you the periodic table. Okay, here's the periodic table you will be given in the exam. Okay, you will be given this. You guys can cheat. Okay, so he put all the elements in columns like this, and he put them in rows, horizontal rows like this. What are the two rules we took last year? Nothing new here. What are the two rules that we studied last year? Columns are called what in the periodic table? Columns are called what in the periodic table? Columns are called groups. Thank you very much. Yes. And they represent what? They represent what? If you know the group number, you know the number of Thank you, Jannah. Thank you, Razan. Thank you, Dua, Noon, Farida, Lamis, Ahmed Hatem. That's amazing. Fairuz, Rines. Excellent. You can know the number of outermost electrons. And so, for example, lithium had, let me go back to this lithium. Lithium had one outermost electron. Therefore, it's in group. Thank you very much. Exactly. It is in group 1. Okay? So that's the first rule. And we have total how many groups? 8 groups. Thank you very much. Now, the new thing this year, last year, you guys noticed the transition elements. Exactly that. You guys noticed the transition elements here in the middle. And you were like, oh, miss, these elements in the middle, they do not have a group number. And I'm like, yeah, last year I said they do not have a group number. This year in your periodic table, they updated the periodic table. You're going to find 2 differences in the periodic table this year in the AS level, okay, compared to O level. Last year, we just called them groups 1, 2, 3, 4, 5, 6, 7, and 0, or 8. Okay, so 0 and 8 are both acceptable, although 0 is more correct. But anyhow, we'll let go now. Truth is, they have these numbers between brackets. So they gave the transition metals groups 3 to 12. And now group 3 can also be called group 13 if they consider the transition metals. Okay? And group 4 is now called group 14, and group 5 is now called group 15. Group 6 is called group 16, group 17, and group 18. Okay, so that's one difference in the new periodic table for the AS. It's a tiny difference. Guys did not complain. Okay, nobody complained so far. So good. This group has an amazing attitude. I love you guys. The second difference is what? Yes, Razan, exactly. What is the second difference? There's a small, tiny, one more difference. Last year, they used to approximate or they used to round up or round down the mass number. Okay, now, and here they have the mass number in decimals. How come the mass number is in decimal? It's supposed to be a whole number. It's protons plus neutrons. However, there's a reason, because we have more than one isotope, so we take the average, and so we end up with decimals. So you're going to find these decimals here, okay? All right, now what about rows? What are they called? Excellent. Farida, Nisreen, Dua, Dalia, Fatima, Razan, Lean. Look at you guys. Rines, Mena Phillips, Lara, Ahmed Hatem, Fairuz, Sifuddin. Excellent. Yes, we call them periods. And what do they represent? If we have the row number, the period number, it means we have the number of shells. Thank you very much. And how many periods do we have in total? Or have we discovered in total? We have 7 periods total. That's amazing. All right, guys, I'm gonna give you an exercise, okay? And I'm gonna leave you for a second. I want you, do you guys have the periodic table in front of you? I want you to find the number of outer electrons in iodine and the number of shells in iodine. And I want you to do the same for sulfur. Okay, by the time I come back, it's gonna exactly be 1 minute. I'm gonna go get myself some water. Number of outer electrons and number of shells. And if you guys still remember the electronic configuration, okay, do that for sulfur. Do that for strontium. Let's do it in another color here. Okay, do that for strontium. I want the number of outer electrons. I want the number of shells. And I want you to do the same for potassium. Outer electrons, number of shells, and electronic configuration also for potassium. That was something that was really important, okay? All right, so guys, you have, I think 1 minute is enough, Saf, right? How many minutes is enough? Oh, look at you, Razan. Oh my God, she already answered. Okay, let's take just less than 2 minutes, all right? And I will be back right away. This is an amazing group. Amazing group. Look at this. Oh my God. Whoa. Okay. Razan answered correctly. Thank you very much. Noon, Dua, Saifuddin. Correct, Saifuddin. Thank you. Mariam Mohsin talked about iodine. Noon, now potassium. Okay, so she's answering one by one. Yahya talked about potassium. Thank you, Yahya. Ammar talked about iodine. Ahmed Hatem, oh, look at this answer. Complete and nice and organized. Nice. Farida, thank you. Adam, Lujain, Lean Yunus, nice. And you guys did not have to find the electronic configuration for iodine or strontium because that's something we will learn this year, okay? Okay, so Rabia is watching you guys and she's, yeah, that's amazing. Nice, look at you guys. Okay, so as we know, okay, so restart. Okay. As we know, this is period 1. Okay, this is period 1, which is the hydrogen and helium. They have one shell only. This is period 2, this is period 3, 4, 5, 6. And so iodine is period 5, so it has 5 shells. It is group 7 or 17. Sorry about the confusion in the update. And so it has 7 outermost electrons. Easy? Okay. Sulfur. It is period 3, so 3 shells. It is group 6 or 16. And so it has 6 outermost electrons. Now, it has 16 protons, and therefore 16 electrons. And so these 16 electrons, we can arrange them as 2, 8, 6. Why 2, 8, 6? Why? Because the first shell is so small, so close to the nucleus, it can only fit 2 electrons. That's it. We cannot take any more. The second shell is a little bigger, a little wider, a little further from the nucleus, and so it can accommodate 8 electrons. And that's why but the 8 is the maximum. And then those 6 the last 6 will go to the third shell. And we talked a lot about electronic configuration last year. You guys remember electronic configuration? Yep. This year we have more details. Okay? Something called SPDF. You guys do not have to worry about it today. You worry about it Friday. Okay? Friday we're going to teach all about this. Okay, potassium is in period 4, and therefore it has 4 shells. It is group 1, and so it has 1 outermost electron. And the electronic configuration was a little weird last year. It is 2, 8, 8, 1. This year, we will know why it's not 2, 8, 9. Okay? All right. Strontium, as you guys all said, is in period 5, so 5 shells. It's in group 2, and so it has 2 outermost electrons. Does anybody have a problem with this? Anyone that has a problem with this? Awesome! Awesome. That was amazing. Okay, you guys are amazing. All right, so with these two rules, we have 2 problems. There are 2 elements that do not follow this rule. Yeah. There's an element that is placed in group 8. Okay? It's placed in group 8, but it has 2 outermost. What? It has 2 outermost electrons. It should be in group 2, not group 8. Yes, you guys are right. Excellent. Lamis, Farida, Razan, Dua, Lujain, Ahmed. Not transition. No, I'm not talking about transition elements. Forget the transition elements now. Dalia, that's right. Mena Phillips, Nasreen, yes. So helium has only 2 outermost electrons, but we did not put helium in group 2. Does anyone know why? It has only 2 outermost electrons, and we placed it in group 0 or group 8. Exactly, Lamis, thank you. Exactly, Razan, Dua, Farida, Leen Yunus, Ahmed Hatem. Look at you guys. Jury, that's one answer. Yep. Fatima Zahra, that's correct. So, group 8, what is so special about group 8? What is so special about group 8? Group 8 has something really special. Everyone in the periodic table has goals and ambitions, and they want to do something, right? They want to reach something. Group 8 is happy. They're like, leg on, yeah, they're like, I'm happy and I'm stable. I don't want to do anything. And so we call them noble gases. Why? Because they are stable. I mean, I know I use the term happy, but it's not the word happy you're going to put on the exam. They are stable. Right? Why? Because they have full outermost electrons. The word full outermost electrons almost always means 8 outer electrons, except if it was the first shell, then it's gotta be only 2 electrons. Why? Because the first shell can only accommodate 2 electrons and that's it. Okay? All right, so that helium is actually an exception. Helium has only 2 outermost electrons. However, these 2 outermost electrons are in the first shell, which means it is the max, which means it's full, which means it is stable, which means it's unreactive. It doesn't want to react. Okay? And that's why we could not put it in group 2. And I think someone said it cannot be in group 2 because it's a gas. Group 2 are all metals and they're solids and they conduct electricity, right? So that's one exception that doesn't follow the rule. Okay? What is the second exception? There's another exception. One more exception. Excellent, Lemis. Excellent, Lemis. Ahmed Hatem, Nisreen, Ammar. Oops. What was that? Oh, that good notes. The good notes keeps doing stuff. That is right. Ammar, thank you. That's it. Ammar, Nisreen, Ahmed, and Lamis. That's it. 4 students. Guys, come on. Where are you? Where's everyone? Where's Jenna? Abdurrahman, Adam, Anas, Dalia, Lamar, Yahya, Fairuz, Tasneem, Sarah, Salma. Where are you guys? Come on, everyone. Rines. What is the other exception? What is the other exception? Okay. You zoned out, Noon? Ah, big trouble. Okay. What do you guys think about hydrogen? Hydrogen has 1 outermost electron, right? Just 1 outermost electron. Scientists some years ago, and that was wrong, they first put it right here in group 1. They said hydrogen has 1 outermost electron, and therefore we're going to put it in group 1. Woo! Big problem. Why? Why is that a big problem? Putting hydrogen in group 1. Because Mendeleev, he put everything that has 2 outermost electrons in group 2, everything that has 1 outermost electron in group 1, and everything just fit perfectly. And everything that has 7 outermost electrons in group 7, and they were perfect. Why were they perfect? Because they all matched in properties. Everything in group 7 behaved very similarly. Not only that they had 7 outermost electrons, but they behaved similarly. Group 2, same thing. They behaved similarly. Just like siblings, you know how siblings act, especially in public? They behave similarly. I mean, you can tell this is the family of so-and-so, right? Yeah. Group 1, lithium, sodium, potassium, rubidium, cesium, they all behave very similarly. And so when they put hydrogen here, ooh, it was odd. It was really different. It did not behave similarly at all. Yes, it has 1 outermost electron, but it is not a metal. It does not conduct electricity. It is not a solid at room temperature. It's actually a gas. It's flammable. It's very, very different. And so they said, we cannot have hydrogen right here. We've got to move it somewhere else. And so they put it in a really random place in the periodic table. They put it just in the middle. All right. Okay, so that's hydrogen. So hydrogen is actually the second exception. Hydrogen has 1 outermost electron, but it's not in group 1. Why? Because it doesn't behave like group 1. It doesn't look like group 1 at all. Okay, it's not a metal, it's not a solid, it doesn't conduct electricity. So it's really, really different. Okay, so guys, in my first slide, my first statement in my slide was what? What was it? What was the first statement? The one that with the heart. Chemistry is happiness. Thank you, Lamis. Chemistry is happiness. All atoms want to be happy. They want to be stable. And so atoms themselves are neutral. Why? You guys remember when I think Dalia was the one who said the protons are equal to the neutrons. And so overall, since they're equal, there's no overall charge. And so protons are, when they're equal, it's neutral. Okay, so atoms are neutral. However, atoms do not just stay like that. They have goals. They have ambitions. Like, you guys should have goals in your life, right? Does anyone have a goal yet? I know you're teenagers, but does anyone have a goal, a big goal, like cure cancer, something big? Razan has one. Lamis has one. That's really funny. I love it. Yeah. Anyone else? You guys should start having goals. My kids do not have goals yet, and I keep bugging them. I'm like, stop gaming and stop wasting your time and go find your life project. And my daughter always makes fun of me, and she's like, I don't want to find my life project now. I want to sleep. Oh, Dalia, yes, that's a really good goal. Full marks. Yeah, I mean, getting full marks in the AS is a good goal. Okay, so back to the atom story. Atoms also have goals. They want to be happy. And so they do stuff, right? They either lose some outermost electrons to be stable, to be similar to noble gases, or they gain some outermost electrons, or gain electrons to the outermost shell to be stable and be happy. Now, if they lose electrons, are protons and electrons equal anymore? They lost electrons. And so now the electrons are less. What's more now, the plus or the minus charge? What's more now, plus or minus charge? Just put the... Excellent. Look at you guys. Thank you. Yes, Yahya, thank you. Finally participating, Yahya. The plus charge is now more. And so the overall charge of the atom, it's not an atom, by the way, now. Charged particles are called ions. So the overall charge of the ion is what? It's meow. It's a positive, and we call it what? Why did I say meow? Yeah, because those ions, we call them ions. We call them cations. All right? Okay. If the atom decides to gain electrons, now what's more, the plus or the minus? If it gains electrons, what's more, plus or minus? Yeah, the minus is more, the number of electrons is more, and so the overall charge of the ion is... Oops. Yee. Okay, the overall charge is... Yes, exactly. It's going to be negative ion, and negative ions are called... Thank you very much. Ahmed Haytham, Razan, Nisreen, Farida. Look at you guys. They are called anions. Thank you very much. Okay. Now let's get to a little bit of hard stuff, but you guys are smart. This group is really, really smart. How did scientists know that atoms, even though they are overall neutral, how did they know they contain oppositely charged particles? Because 200 years ago, someone came in and they said, okay, this small piece of paper, I agree with you guys, it has millions and billions of particles. We're going to call these particles atoms, and these atoms are spheres. He said they're just boring spheres. And then came a scientist called Thomson. And Thomson said, no. I did an experiment. And these atoms are not boring spheres. Yes, the overall charge is neutral. The positives cancel. There are positives and there are negatives, and they cancel each other. And so he said, no, you do not have, Fairuz, you do not have to know the name of the scientist. Only AQA students have to know that. We only have one AQA student. Her name is Minna. She's not here today. So AQA students have to know the name of the scientist. You guys do not. You do not have to know Thomson's name, okay? But Thomson came, and he said atoms are not boring. Atoms contain particles in it. It's not just one sphere, but it has stuff in it. And these stuff are oppositely charged. And there's positives and there's negatives. How did he know? He applied some kind of voltage to a piece of metal. And when this metal was exposed to voltage, something left the metal. Something small left the metal. So he's like, oh, this metal is atoms, right? There's atoms in this metal, but something left it. Something light and small left this atom. So there must be subatomic particles. Now, you guys remember from last year, the structure of metals, right? This is a metal. What do we remember from last year is that metals have free delocalized electrons. Okay, Maysam, Maryam, I'm going to repeat. Thomson came and told scientists, hey guys, atoms are not boring spheres. They're not just simply spheres that have no charge, no nothing. They actually have something inside it. They have tiny light particles inside it. And these particles have a charge. They are charged. Charged means they can get attracted to the opposite charge of it. Okay? So far, so good, Maryam? Now, how did he know that these tiny particles, actually, these tiny particles are completely transparent. You cannot see them. But if you make them hit a fluorescent screen, it's going to glow and you're going to see a glow. Okay, so electrons will hit the screen and make it glow. Okay, Maryam, so far so good? All right. Now, how did Thomson know that this electron beam is negatively charged? How come, like, why is it not positively charged? And how did he know it's charged in the first place? So what he did is he put something, a plate that is charged above and below the device. So this is the device. He put a plate above and below. And so here's the device again. I drew it. He put a positive plate above it and a negative plate below it. Now, how do you make it positive and negative? Expose it to electricity. Apply some voltage to it. Okay? Now, this beam of electrons was originally moving in a straight line. Now, after you put these plates, when Thomson put these plates in another experiment, he was just, you guys know how many experiments he did? Thousands, okay? I'm talking about the summary of experiments. He did thousands of experiments, and I'm just talking about the summary of all of this, okay? Yes, the one below is negative, okay? So this one below Lemis is negative, all right? Yes. Now, this beam of electrons, he did not know it's negatively charged. He did not yet call them electrons. He just knew there's a beam, something, some kind of particles leaving the metal and moving in a straight line. And so he was like, I wonder if this beam has a charge and what charge it is. What's the device name? You guys do not have to know the device name, but it's called cathode ray. It's called cathode ray. Okay, Noon? All right. And so he was like, I wonder what charge are this beam of something, these tiny particles that are leaving. And so he exposed it to charged plates. Do you think this beam of electrons, now we know it's a beam of electrons, he did not know. Do you think this beam of electrons will move in a straight line now that we have these plates? Do you think it's going to still move in a straight line? Excellent, Jannah. Excellent, Judy. Okay, it's not. It's gonna move. It's gonna deviate. Is it gonna deviate up or down? Is it gonna bend up or down? Thank you, Ammar, Lamis, Razan. Look at you guys. Yes, it's gonna deviate up. Why? Because it's gonna attract to the positive. They are negative and they're gonna be attracted to the positive, and so they're gonna deviate up like this, and the fluorescent screen will glow a little bit up. So he's like, boom, voila, I made a discovery. There's something negatively charged in the atom. And we know that atoms are neutral overall. So he said, okay, atoms are positive and they contain something negative in them. Okay, so that was his experiment. Now, scientists came and they did millions of experiments. And so years after Thomson, scientists were able to actually move a beam of everything in the atom. They were able to move a beam of each type of the subparticles. They were able to move a beam of electrons like Thomson. They were able to move a beam of protons, which like is really difficult, but they were able to do that through a series of experiments. You guys, again, you do not have to know any of this. You just need the summary. Like, for example, the question, is it going to deviate up or down? That's it. Oh, you took this in physics. Wonderful. Okay, that makes my job way easier. They were able to move a beam of neutrons. They were also able to move a beam of atoms, a beam of ions, everything. Okay? And so, my question for you is, if you move a beam of neutrons across a device that is surrounded by a positive plate and a negative plate, is it going to move in a straight line, or is it gonna bend up or deviate up or deflect up, or is it gonna deflect down? Awesome, look at you guys. That is correct. All of you are correct. I think I have like 8 students who answered. Where's everyone else? Yes, neutrons will move straight. Why straight? Because neutrons are neutral, right? They do not have a charge. Okay? All right, what about electrons? Electrons, are they gonna go straight, up, or down? Yes, they're gonna go up. Okay, so electrons are gonna go up because they need to be attracted to something positive. Thank you, Rines, Ammar, Ahmed, Lamis, and Jannah. But my question is it gonna deviate slowly and far, or is it gonna deviate quickly and sharply and very close? Far or close? Sharp or like big angle? Yeah, close and fast. Why? Close and fast. Why? Excellent. You guys are so smart. Yes, it's going to deviate right away, very quickly, very sharply. It's going to turn quickly like this. Boom. Why? Because electrons, thank you, Lin Yunus, Anas, Yahya, Dua, that's amazing, wonderful. Tasneem, thank you very much. Amr Tamer, very much. Excellent. Because they're very light. And so they turn very quickly. All right, now, what about protons? Protons will deviate or will turn what? Will turn to the negative, will turn down, will deviate down, will deflect down quickly and sharply, or it's going to be far. Far, 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 like this. Why? Because it's heavy, right? It's gonna be 2,000 times as far as electrons. Oh, Dua, that's a good one. Dua said because it's pregnant. Okay, so last year I was talking about how heavy masses move slowly, and I gave an example of me when I was pregnant, and I was just so fat, so slow, so lazy. And that's exactly it. Protons are 2,000 times as fat and heavy as electrons, and so they're so lazy. Okay, and so they don't turn easily. I did not turn easily. Like, for me to get out of bed, oh, I had a big angle of like, oh my god, it was so hard. Okay, so now we want to talk about another topic which is very, very related. Oh, Razan said I was not fat. Oh my god, I was so fat. I'm gonna send you a picture of me. I was like, yeah. Okay. The second topic, it talks about isotopes. So, scientists so far discovered 118 elements, all right? However, here's the news. Here's the surprise. Each element has types. So, oxygen is not just oxygen. There's 3 types of oxygen. Argon, not just argon. There's 2 types of argon. Neon, 2 types. Carbon, 3 types. Hydrogen, 3 types of hydrogen. Chlorine, nitrogen, 2 types of each. Have you guys ever went to a car dealership and then you choose between BMW, Volkswagen, Lincoln, Toyota? Okay, you choose the brand. And then after you choose the brand, they surprise you by saying, oh, you've got to choose the model. Yeah, one more choice, one more thing. There's types of each car. Ugh. Right? Have you guys been in that situation? I've been in that situation. I'm not into cars. and so if you go, for example, to a BMW, all right, and you already chose BMW, you think you're done. You know, I think I'm done. I want to sign the papers. I want to pay and get out of here. But then they say, you've got to choose the color because BMW makes different colors of cars. They make 75% of their cars in gray, and they make 25% of their cars in red color. Guys, how's that related to chemistry? Can anyone tell me how's that related to chemistry? Exactly, Roseanne. Thank you for spamming the chat. Isotopes. Exactly. There are types. Which isotope do you think this is? Which isotope do you think this is? Does anyone know? Carbon has 3 isotopes. This thing has 2 isotopes, and it's 75% and 25%. Common, well-known, you guys have to know it. Okay, so this is similar to chlorine. All right? Chlorine is chlorine. It has 1 identity. It has 17 protons. Oh, well, you guys are Edexcel. I think the smaller number is up. Okay. All right. Right? Now, the mass number could be different. So 75% of chlorine that got created is lighter in mass. It has a mass of 35, which means the number of neutrons, 35 minus 17 is 18. Okay? And 25% of the chlorines in the universe are the heavier kind of chlorines, and they have and they have a mass number. They have a mass number of 37, which means the number of neutrons are 20. You go to another dealership and you pick Toyota. And then after you pick Toyota and you're ready, they tell you, oh, hold on 1 second. Toyota makes 3 kinds of cars. One that's blue, and so 99, Toyota makes 99% of their cars blue, right? And 1% purple. And if you're lucky, you're going to find a rare car that's orange. How's that related to chemistry? Which element has 3 kinds, 3 isotopes with these percentages, 99%, 1%, and rare? Excellent. Carbon and hydrogen. Exactly. Carbon and hydrogen. So hydrogen, for example, has only 1 proton, atomic number 1, right? But there's different kinds of hydrogens. The most common, the blue car, the 90%, 99% of hydrogens have a mass number of 1, which means number of neutrons is 0. 2% have a mass number of 2, which means neutron number is 1. And rarely in the universe, very, very rare, you will find hydrogen 3, which means neutron number is 2. All right? So, but in all cases, it is still a Toyota. It is still a BMW. The identity is the same. The atomic number is the same. What identifies elements? I'm repeating. This question is I already covered it in the first few slides. What identifies elements? Thank you, Noon. Thank you, Jannah. Thank you, Lamis, Farida, Dua. The number of protons. Nothing else. Thank you, Tasneem. Nothing else. The number of protons is the identity of elements. All right? And so elements are like cars. They all have the same number of protons, atoms of the same elements. They all have the same number. Sorry, I was distracted by some text here. So just to let you guys know, I cannot read long sentences. Miss Nervana is used to me spamming. Okay. Yeah, Roseanne is one of my favorite. All of you guys are favorite. I love you all. All right. And the new students, you guys are my favorite too. If you're here and if you're participating, you're my favorite. Okay. So atoms, just like cars, same element would have different kinds of atoms like car models, okay? Just to increase the confusion of everything. And so everything is the same. The number of protons are the same number of protons, same number of electrons. All right, if it's an element, of course, and if it's the same number of protons, it means it's the same element, right? What's the only difference? What's the only difference? What's the only difference in the subatomic particles? Neutrons, neutrons. And if the number of neutrons are different, we're going to call them isotopes. Thank you very much. Now, here's the thing. Almost all elements in the periodic table have isotopes. Some have 2 isotopes, some have 3 isotopes, some have 4 isotopes, some have 5 isotopes, some have 6 isotopes. It's crazy. Maybe only 2 do not have any isotopes, like I think fluorine and aluminium do not have isotopes. But other than that, everybody has isotopes. Scientists were gonna do something. Fortunately, they did not do it. They did not proceed in that horrible idea. They were about to give each isotope a completely different name. Completely different name. So they, for example, neon has 2 isotopes. They were going to call one of them neon and call the other one something else. Yeah, Noon is like, bro. I know, horrible idea. Goodness, fortunately, they only did this for one element, only one element. I don't know if you guys can guess. Only one element. Excellent. Lemis, did you watch my pre-recorded video? I think you did. Amazing. Yes. Okay. So only one element, Rines, that's right. It's hydrogen. They did it for hydrogen. But fortunately, they did not do it for all other elements. So fortunately, both isotopes of neon are called neon. But we're going to call this neon 20 and neon 22. Neon 20 is 90%, neon 22 is 10%. This is a visual picture of I mean, you cannot see this, right? Because atoms are so tiny and small. But if you were to see them, a sample of neon is going to look like this. Most of it is neon 20 and only 10%. Did you guys recognize the 10%? It's a little bit of a lighter green color, but it's blending, right? It's a little bit heavier, okay? So only 10% of the neon is a little bit heavier. Question. If the examiner asks you on the exam to define isotopes, what are you going to say? These are atoms. Same element or different element? Do they belong to the same element or different element? Same element, of course. They have the same identity. And they have the same number of protons, but different number of neutrons. Excellent. That's the definition. Guys, if you get a definition in the exam and you lose a mark, seriously, you gotta be kidding me. You're kidding me. You cannot lose marks on definitions. Definitions are the easy marks, are the free marks. Yes. Okay. All right. So I have another question for you. Instead of saying same number of protons, can you say same something else? Can you say what? Instead of same number of protons, can you say exactly that means you can say same atomic number. Okay. And instead of different number of neutrons, can you say different? Aha, different mass number. Exactly. Thank you. Yes, you can say that. It doesn't matter. All right. Another example of isotopes, chlorine. Chlorine has 2 isotopes. There's chlorine 35 and there's the heavier chlorine 37. Chlorine 35, 75%, three-quarters of chlorine in the universe are the lighter one. Yes, I will send this, Judy, after class. And if I don't, usually one of the students will remind me and I will post it right away. Okay, so do not worry. Yeah, I will probably forget. So someone remind me. Razan will remind me. Razan is actually on my team right now. She's an assistant, so that's amazing. Okay, and 25% of chlorine is the heavier one. And guys, you do have to know this information. Some students will say, oh, do we have to memorize? You don't have to memorize, but by the time you solve my homework, you will memorize this, and you do need to know this, okay? Yeah, Rosetta is like yes and no. It's not hard, exactly. Exactly, no, thank you. All right, third kind of isotope. Do you guys know that your whole body is made of carbon? Do you guys know that? Your whole body, you're just carbon, 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 carbon. All right. Carbon has 3 isotopes. There's carbon 12, there's carbon 13, and there's carbon 14. They are all 6 protons. All of them are 6. The most common one, 99%, is carbon 12. 1%, just like Toyota, right? Making most cars blue, but then once in a while, 1%, you're going to find a purple car. And then rarely, exactly that, rarely, you're going to get really rare, you're going to find this carbon 14. And yes, Dua, she was here yesterday. I was telling to yesterday's group, guys, I want you to brag to your families. Like while sitting in the, lunch, while taking lunch together and on the dinner table, I want you to brag to them and say, we're made of carbon. Now, if your parents are doctors, they will know. Or like if they're in the medical field, they will know that we are made of carbon. But your siblings won't know. And then you can, brag to them. And I was a very mean sibling when I was younger. Okay, next one is hydrogen. And that's the one. Yeah, Razan is an older sibling. She has your younger brother. His name is Ied. Yeah, Ied, exactly. And he's gonna be in my class. And Dua is an older one too. Her younger one is called Doha. So yes, see, I'm good at remembering names. Hydrogen. Ahmed Hatem, do you have younger siblings? I wonder. I'm just curious. And Omar Tamer has one younger sibling, right? Ali, see? Laura, you also have younger ones. Good. Noon. Miss, I love how you I will convince my yes, Noon. Maryam, I'm the middle child. Not bad at all. You still have someone younger to torture. I was the oldest. Being the youngest is the best. Farida's youngest. Ooh, Fatima, that's amazing. Cannot wait. We're starting Wednesday, so make sure he joins on time because we already have a homework and we started grading Fatima for the O level. 2 younger sisters, Lujain. That's amazing. Ooh, a lot to torture. You can have a lot of fun, Lujain. And Judy is also the oldest one. It's so good to be oldest. I'm sorry, guys. I'm so mean. Mena Phillips is the youngest. I had a feeling you're the youngest. I don't know why. All right, so back to hydrogen. Hydrogen, they are all atomic number 1. They all have the number 1. But most hydrogen have a mass number of 1, which means 0 neutrons. 99% of hydrogen are 0 neutrons. Okay? 1%, just 1%, is a little heavier and has 1 neutron, and therefore the atomic mass is going to be 2. It's hydrogen 2, and then rarely there's hydrogen 3. Now, scientists did something that students do not like very much. They do not like at all, actually. What did they do? They named each of these hydrogen a different name. Yep, different name. So the hydrogen 1, which is the most common, they called it protium, and the symbol is still hydrogen. The heavier hydrogen, hydrogen 2, they called it deuterium, and the symbol is D. And the third one, they called it tritium, and the symbol is T. Those of you who learned French, I learned French way when I was in elementary school, and I still remember the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 1, 2, 3. 1, 2, deuterium. 3, tritium. Okay, and so you can remember the numbers this way. And so you actually do have to know, and this is in your pop quiz, guys. When you're done with the lesson, go to the website, make sure you enroll, make sure to go take your pop quiz. This is one of the pop quiz questions. Razan, did you take the quiz yet? Not yet? So I don't have all the pop quizzes ready, but I did one for 1.1. So hopefully I do a pop quiz for each lesson, okay? Which is a really short quiz that is a lot of fun. It is not in a form anymore. Saifuddin, you like the form? The form was so bad. It's outside the website and we have to... How many marks? 5. Yeah. You preferred the form? Oh, yeah, the reflection. That's why you like the form. You like the reflection. Okay. Now, question. How did scientists know? How did scientists know we have isotopes? Because again, guys, you cannot put this on the mass, on a balance. You cannot measure the grams, right? You cannot do that. So how in the world did they know that most hydrogens are light? And then a little bit of them are twice as heavy, and rarely, just a little bit of them are 3 times as heavy. Like, how did they know this? From Thomson's experiments, they developed a device called mass spectrometer. Mass spectrometer. What time is it, Mana, at your place? It's not even 8, right? What time is it? Let's oh, timers, world. I don't have Dubai here. So anyhow, okay. It's 8:30 UAE. Oh, that's why, Mena. Oh, that's why. Okay. 8:30 UAE, not bad at all. Okay, not bad at all. All right. So they developed a device called mass spectrometer. Now, everyone focus because this is like brand new for you here in the AS. Okay, so if you've been zoning out, which would really make me upset, yeah, if you've been zoning out, please wake up. Okay, please wake up. All right, so this mass spectrometer was a device that could tell you if you have something of the same mass or you have different masses. Before I talk about the mass spectrometer, I want to tell you about a story. Who likes story time? Story time? Yeah, me too. I like story time. Okay, so let's talk about a race story. Okay, so we have this race ground. Okay, it's a little bit bent. Okay, it's not all straight line, it's a little bit bent. And here's the finish line. Okay, and we have many participants. We have maybe 100 participants, but we're going to only draw 2. And each participant represents an atom. Okay, and these are atoms that have different isotopes. Some of them are heavy, some of them are light. So I'm going to draw the participants or the isotopes. The light ones are like this, okay? Light ones, light participant, and some heavy participants. Here's a heavy participant, okay? And we're asking the participants to run in this race thing, and we're gonna force them to bend a little bit right here, and we're gonna detect them. Guys, pay attention to these words. We're gonna detect them at the finish line, okay? So we're gonna make them accelerate, speed up, move quickly. We're gonna ask them to accelerate, run quickly, and then we're gonna ask them to bend right here, basically deflect. Deflect, okay, is the scientific word. Bend is a term me and you are using, but the scientific term is deflect. We're going to ask them to deflect or bend at a certain point, and then they're going to be detected at the end, okay? So we started the race, we asked the participants to run, and then to make them accelerate, to make them move faster, what did we do? We put some audience right here, some people right here, to cheer them up and tell them, hey, move faster, faster, faster. And then the participants will do what? They're going to actually move faster, faster, faster. And then we want them to bend. We want them to turn. We want them to turn. And so we're going to apply some maybe strong wind and make them or force them to turn in this race line, and so they will reach this finish line. Okay, you guys understand the story? Because I have a question for you. You guys all understand the story. Wonderful. Okay, let me ask you a question. Where do you think the lighter isotope, I mean the lighter participant, the lighter runner, where do you think, well, he's running, and then he's going to be forced to bend. Do you think he's going to bend a little and appear here at point A? Or do you think he's going to bend a lot and appear in point B? Bend a little or a lot? Little or lot? A or B? Excellent. Jannah, Noon, Farida, Razan, Lamis, Lujain, Mana Phillips, Lamis, Adam. Excellent, guys. You guys are amazing. Nasreen, thank you very much. No, Nasreen, this is a light guy, not heavy. He's a light guy. I'm going to repeat the question. Okay. This is the heavier one. Okay. What do you think about the heavier one? Let me repeat the question in a different way. Okay. What do you think about the heavier one? Is he going to bend just a little or bend a lot? Do you think the wind will affect him a lot? Aha, okay. So the lighter guy, the lighter participants will bend a lot. A lot. Why? Because they're light. They don't have much mass. And so it's easy to deflect them and make them turn. The heavy guy is not going to turn much. And so he is not going to deflect much. Do you guys all understand this? Nisreen, do you understand this part? Wonderful. Amazing. What does that have to do with chemistry? Yes, chemistry is the same thing. The same thing. We bring a device that looks a little bit bent like this. Okay, so it looks like this. It's a little bit bent. Okay, this device is called mass spectrometer. And it tells you if something is heavy or light. And what we do is we introduce the sample right here. Okay, and we make them run fast in this place. This is called an accelerator. I'm going to tell you how it works. We make them move faster in this place, and then we're going to force them to deflect in this area. This is the deflection. And guys, you are required to label a mass spectrometer. So maybe they will have they may have a diagram for you on the exam paper, and they will ask you where's acceleration, where's deflection. Okay, this is physics. Wonderful. I like it when there's like overlap in the sciences. And then these isotopes will move, and they will deflect, and they will be detected at the end. Detected, so detection is at the end. Omar Tamer, I have not seen your participation in a while. Please do not tell me you who have zoned out. I would really be mad. Ah! Are you zoned out or focused? You're listening. Okay, good. Okay, listening and enjoying. That's wonderful. All right. And so, do you guys understand what happened? The element will be introduced in this place. This element might have 2 isotopes, 3 isotopes, 4 isotopes, 5 isotopes. They're going to accelerate in one area. They're going to deflect in one area. And then they're going to be detected at the end. Okay? And so if you have 2 isotopes, the lighter isotope will deflect a lot. And the heavier isotope will not detect very much. Will not deflect very much. If you have 3 isotopes, they will be detected like that. If you have 5 isotopes, they will be detected like that. And so that's exactly what scientists did. They introduced chlorine and found 2 isotopes. They introduced carbon and found 3 isotopes. They introduced iron and found 5 isotopes. All right? Okay, question. Do you think the sample that will be introduced here, do you think it can be any state of matter, solid, liquid, gas, anything? Or does it have to be something in specific? Jannah, correct. First to answer. Dua, Lamis. It has to be a gas. Guys, we're going to move these participants and make them run a race. How do you think they're going to run a race if they are solids or liquids? Okay, so If your sample is a solid like iron or sodium, or if it's a liquid like bromine, make sure they become a gas. And so we have to vaporize the sample. All right? Okay. Second question. If you want to control the movement of something, you want to accelerate it in one place, you want to deflect it, bend it in one place, you want to detect it in one place, is it okay if it's neutral atom or you have to make it charged? If you want to control, I'm going to repeat my question. If you want to control, excellent job, Yahya Mahmoud, excellent. If you want to control the movement of something, you want to accelerate it, you want to deflect it, you want to detect it. Do you think it's easy to control these things if they're neutral or they have to be charged? Excellent, Jannah, Farida, Fatima. Actually, Fatima, there are many uses of mass spectrometer, okay? Yes, they have to be, thank you, Ammar, Lamis, Dua. Okay, they have to be charged. If they're neutral, it's very difficult to control where they're going or detect their place. And so they have to be charged. And so I'm going to do something called ionization at the beginning. Ionization means I'm going to force it to become an ion. Now, not all atoms want to be ions. So for example, if I'm introducing a sample of argon, argon does not want to be an ion. It wants to be an atom. So I'm going to have to force it to become an ion. Scientists found a way to force something to be an ion. How? Shoot it with a gun. What? Like a real gun? No, not a real gun. An electron gun. A device that shoots electrons at a very, very, very high speed of electrons, a beam of electrons that causes the atom to lose one electron. It snatches one electron from the outermost shell. So argon, for example, loses an electron and becomes argon plus one. Or any element, aluminium, iron, any element, lose one electron and becomes positively charged. Now I have these positively charged things. Easy so far? So far, so good? Okay. Now, if we force them to become ions, they're not really forced to move. We want to accelerate them. We want to cheer them up. We want them to run quickly. We want them to move through the device. How can we move them through the device? Scientists thought, okay, let's put an anode here. A positively charged plate. Let's put an anode here. What's the anode gonna make? What's the anode gonna do? Repel those cations. Are you guys following? We have cations right here that became positively charged. We're gonna force them to move by having an anode. The anode will repel them, and so they're gonna try to escape the anode, get repelled, and move quickly. And that's how the accelerator works. So far, so good. Can I move to the next thing? Wonderful. Farida, Dua, and Razan and Nisreen are responding and telling me they understand. Yes, anode is positive, Yahya. Yes. Okay. After they move quickly, we want them to turn. Why do we want them to turn? Because if they turn a lot, we know they are light, low mass, small mass. If they turn a little, we know they have heavy mass. So turning is important. Now, how do I turn these cations? By applying an electromagnetic field. This is truly physics. You guys have that left-hand rule? Like how electricity moves if you have an electromagnetic field? Yes. So when you have an electromagnetic field here, it forces the cations to move in the device. And so the light cations, the light isotopes will turn a lot. The heavy ones will turn a little. Okay, to summarize this, for exam purposes, you should know that the sample should be vaporized, should be gas. You should also know that we should ionize them and make them positively charged. You should also know that there's a part that's called acceleration here at the beginning that we make it accelerate using an anode. Okay, Noon? These come in the exam. And then you should know that we do deflection using an electromagnet. And then at the end, we do detection right here. You should know that low masses will deflect a lot more than heavy masses. Okay? Now, when you're doing this electron gun, the purpose is to make it positively charged and make it a cation. Now, usually most of the atoms will just become a positive one, right? Because it requires energy to snatch an electron. Is it possible? Do you think it's possible that maybe, just maybe some atoms will lose 2 electrons and become positive 2? So for example, argon lose 2 electrons and becomes argon plus 2. Actually, yeah, it's rare because it requires a lot of energy, but just some atoms will lose 2 electrons. We do not want this to happen. It just happens like, it just happens, and fortunately, it doesn't happen very much. Okay, so like every once in a while, like 0.5% in every 200 atoms, maybe one will lose 2 electrons. Okay. Why unfortunately? Because when we read it, so why that's a good question. Why unfortunately? Do you think the deflection of the +2 is the same as the deflection, the turning of the +1? Which one deflects more, +2 or +1? They have the same mass, same heaviness, same heaviness. Which one deflects more? Okay, +2 deflects more. It has more charge, so it deflects more. So it like appears like right here. Okay? All right. Last question before we start practicing. Which charge deflects more? +2 or +1? Which one has more deflection? Because then we're gonna have more peaks. So guys, this mass spectrometer is gonna give us a chart. It's gonna give us a peaks, you know, it's gonna kind of look like this, right? And each peak is one of the cations. And so if you have 2 peaks, it means we have 2 isotopes. If you have 3 peaks, it means you have 3 isotopes. And Razen, if you get the +2, it's gonna give us another peak. So it's gonna confuse us a little. Yeah, do you get it now? Okay. Razen, do not worry. We have a whole lesson about this. A whole lesson. We're going to talk all about mass spectrometer and the chart and reading the chart, and like, it's a lot of fun. Okay. Which one turns more, +1 or +2? +2, not same mass. Was it, who was asking this? Ammar. Same mass, but this is a +2, so it's going to deflect more. Okay. My next question is, which one deflects more, the lighter isotope or the heavier isotope? Which one deflects more? More. Which one deflects more? Thank you. The lighter isotope deflects more, so the smaller mass deflects more, the higher charge deflects more. And guys, that was our lesson. Believe it or not, what do you guys think of AS? We're gonna start solving now. Okay? Let's take maybe 1 minute break. It's easy, right? Let's take a minute break. Yes, Omar Tamer. Okay? And then I have how many questions? And then we have Kahoot. 1, 2, 3, 4, 5, 6, 7, 8 questions. And then we have a Kahoot. All right? So let's solve. I'm going to be back in 1 minute. You guys have 1 minute to think of this question, and then I'm going to be back. Okay? All right. All right. Students have already started answering. I love it. Okay. And guys, these are Edexcel past papers, okay? You will see how it is so easy to get the full mark in an exam past paper. I personally do not see anything tricky. It's very easy. Okay. The first question here, the first column is the number of protons. Guys, when it comes to number of protons, do not think too much. Why? Because the number of protons is the identity of the element. It's a fixed number. It doesn't change. Yes, this is AS, Saifuddin. Saifuddin is asking, is this AS? See? See how easy it is? Yes, this is an AS exam. Can you imagine? All right, so number of protons is a fixed number. What do you think about the number of protons of this element? It's the smaller number. It doesn't matter if it's at the bottom, if it's at the... It doesn't matter. It's the smaller number. Thank you very much, Farida, Lamis, Nisreen, Dua, Lin, Mayar, and Farida. Oh, Farida again. So it is 45. Wonderful job. Okay? It is 45. All right. What about iridium? This second element, IR. How many protons? The smaller number. Thank you, Jannah, Nisreen, Lamis, Noon, Dua, Adam. Exactly, 77. What about this other one? It's the same thing. It's an isotope, so 77. Okay? All right. What about number of neutrons? How do you get the number of neutrons? It requires a little bit more thinking, but not too much. Exactly, Lean Yunus. You minus, you subtract. So the first one here is going to be 103 minus 45, right? Thank you very much. And that was 58. The second one is going to be 191 minus 77. And that happens to be 114. Sorry. And then this is going to be just two more. It's going to be 116, right? Because it's an isotope. This is, how do I know it's an isotope? It's the same element, same proton number, but different mass number, different neutron number. Easy so far? Stupid easy. Last one. Number of, look at the question. Read the question. Shells. Shells. Where do you get the shell number? Where do you get the shell number from? You go to the periodic table. You see which row it is, which period it is. And then RH, I'm going to go to the periodic table. Find RH. Where's RH? Here it is. Okay, so here's RH. And here is iridium. Okay, so rhodium is period 5, so 5 shells. Iridium is period 6, so 6 shells. Okay? All right, back to the question. So 5 shells and 6 shells. What do you guys think? Whoa, stupid easy. Love it. I think these were like 3 or 5 marks. Okay? All right. The hydroxide ion has a total of 9 protons. Of course, 9 protons. Why? Because oxygen has 8 protons and hydrogen has 1 proton. Okay? How many neutrons and how many electrons? Let's start with electrons. How many electrons do you think there are? Now, electrons are always equal to protons, right? So we should have also 9 electrons. However, this is a hydroxide with, look at this, a negative charge on it. This -1 means I have 1 more electron. And so 9 originally plus 1, and that's going to be 10, right? So we have 10 electrons, right? And so automatically the answer is B, but let's actually solve the number of neutrons, okay? How many neutrons does oxygen have? You go to the periodic table. 16 minus 8 is 8, so 8 neutrons. Hydrogen has 0 neutrons, and so we should have 8 neutrons in total. That was the question, and it was worth 1 mark. What do you guys think? Very easy, right? Okay. All right, next question. The atomic number, what is atomic number? That's the proton number, okay? So atomic number is the proton number. The atomic number of an element scandium is 21, okay? So they have 21 protons. And the mass number of its only isotope, it has only one isotope, is 45. What can you deduce from this number? The protons are 21 and the mass is 45. What can you get from this? If you have protons and you have mass, yes, Lean Yunus, thank you. You can find the number of neutrons. Thank you, Dua and Nisreen and Adam. You can find neutrons. How? How? Minus. Thank you. 45 minus 21. And what is that number? 24. So 24 neutrons. I don't think that was the question. Let's actually see what the question is. Number of electrons in scandium plus 1 plus 1. Okay, original scandium has how many electrons? 21. Original neutral scandium has 21, right? But if it's a positive 1, positive means what? Positive means it lost 1 electron. So 21 electrons and it lost 1 electron. Therefore, it's going to have 20. Excellent, Nisreen, Maryam, Yahya, Omar Tamer, Razan, Adam. Look at you guys. Here's the answer. Was this a problem? Did anyone find it a problem? Did you guys find this easy? Easy, right? All right. Next question. An atom of nitrogen forms nitride. We already know this from last year. Guess what they're asking? Number of protons, neutrons, electrons. Okay, protons. Without thinking, this is the small number. So protons must be 7. This is the identity. It cannot change. Okay? So we're going to eliminate D. Neutrons is 15 minus 7. 15 minus 7 is what? Is 8. Okay, so that doesn't change anything. What is the meaning of -3? What is the meaning of -3? It means, thank you, Farida. It gained, thank you, Nisreen, it gained 3 electrons. -3 means it gained 3 electrons. Originally, it was 7 electrons, and it gained 3 more electrons. And so the total is going to be 10. Duh! Okay. Which of these atoms has the most neutrons? And so for this question, you're just going to calculate the number of neutrons for each. What is it? How do you get the number of neutrons? Subtract. Thank you, Rines, Farida, Dua, and Adam. So the number of neutrons is going to be 115 minus 49. Can you tell me this number? Omar Tamer, thank you. Anyone with a calculator? I have a calculator. Should I get my calculator? Okay, Razan, thank you. 65. She said 65. I trust you. What's SN? SN is 10. Okay, SN is 10. You guys have a periodic table, so yeah, you will find it. Neutrons is going to be 124 minus 50. So that's 74. Thank you, Adam. Thank you. SB is antimony. Okay, weird, I know. 123 minus 51. What's that number? 72. Thank you, Yahya. And last one, tellurium. 124 minus 52. What's that number? 72 also? Okay. And the question is asking for the most neutrons. Which one is the highest? 74 is the biggest number. Duh! I can give this to my 4th grader. Okay, next question. Protons, neutrons, and electrons of chlorine. Protons, easiest, most automatic. You get it from the periodic table. Protons, do not think too much. You get it from the periodic table. How many protons does chlorine have? Periodic table, 17. 17. Excellent. Okay, so I'm going to eliminate D. That doesn't make sense. 20 is calcium, by the way. 20 protons is calcium. Okay, thank you, Rines. Look at you, how fast. All right, next, neutrons. Neutrons, look at this. They gave you the mass number. It's 37. So the neutrons is going to be 37 minus 17. What's 37 minus 17? 20. Yeah, that was already given for you. Electrons. Now, it has a -1 charge. What does -1 mean? -1 means what? It means what? It had gained 1 electron. So originally 17 electrons. Originally, it gained 1 and 1 more electron. And so now it has 18. What do you guys think? So the answer is C. All right. 2 more. Complete the table to put the subatomic particles of iron. Number of protons, where do you get it from? It is actually AS questions, Farida, yes. I swear this is not from A level, O level. This is actually AS. Yes, from the past papers. And it's on your homework. Okay, you get the atomic number of iron from the periodic table. It is fixed and it's 26 protons. Okay? How to get the number of neutrons? Mass number 56 minus proton number 26, and that's gonna be, thank you Ammar, thank you Yahya, I think that was a typo, thank you Farida, 30. Okay, number of electrons, that's the one that confuses people. What is the meaning of +2, guys? What is the meaning of +2? It had lost 2 electrons. +2 means it lost 2 electrons. And so 26 original electrons, and then it lost 2 electrons, and therefore it's going to be 24. Okay? Yes, actually, AS paper. Okay, complete the table to show the number of protons and neutrons. Duh. Ugh, this one is boring. Okay, number of protons of silicon. Number of protons of silicon. Periodic table. Not much thinking. Thank you, Nisreen. 14, 14, 14. All of them are silicon, but it's 3 different isotopes. So silicon 28 will have how many neutrons? The 28, mass number 28, will have how many neutrons? 28 minus 14, so 14 neutrons. What about the 29? It's going to be 29 minus 14, which is 15 neutrons. And then 30 minus 14 is going to be 16 neutrons. And we're done. What do you guys think of AS level? All right. Not bad at all, right? Not bad at all. Okay. Kahoot should be downloaded. You guys ready for Kahoot? Yep, get ready. How many questions? I think 16 or 15. And each question has like 20 seconds. So you guys should be pretty quick. Yesterday's people, like, they answered like in 5 seconds. Yeah. Do I have to have periodic table? Of course, Omar. I sent it on the group. Omar, maybe I did not add you to the group. I should add you to the group. I'm sorry. Like the announcement group. Now let's enjoy some Kahoot. I know. I hope it works for me. Come on. Ooh, here you go. Atomic structure and mass spectrometer. Here you go. Yeah, I think there's like 16 questions. So guys, go to kahoot.it. Those of you who are new to my class, go to kahoot.it and put this pin number 18540. Let's see who joins first. Who joins first? Very excited to see. Dua joined first. Mena, Rosen, Fatima. The other Dua, Nuruddin, Noon, Yahya, Nisreen, Omar Tamer. Nice, nice, nice. Oh, I need more water. More H2O, please. Okay, you guys ready? One sec, okay? Here you go. You got 1 sec. All right, you guys ready? Let's get started. I'm excited. I'm excited. Okay, the pin number will stay at the bottom. Just go to kahoot.it. You will find the pin number at the bottom. All right, three, two, one. True or false? Protons determine the element identity. I should not have put 15 seconds here or 25 seconds. That's a lot. Okay. Look at that. Yes, of course it is true. Everybody got it right. 19 amazing participants. Look at you. What is the mass number? What is the mass number? Protons only. Protons and neutrons. Protons and electrons. Neutrons only. 19 amazing participants. Thank you. Yes, of course. And I think that one fluke is just misclicking, right? Okay. In a neutral atom, protons are equal to electrons. Protons are equal to neutrons. See, 14 people have already answered. I didn't even finish reading that question. That's so good. That is so good. Okay, yes, of course, protons are equal to electrons. Look at the chart. What are the columns of the periodic table? The columns. What do we call them? 15 people answered in 3 seconds. My goodness. Look at you guys. You're faster than yesterday's group. Yeah, that was like, yeah, no time. Okay. So yes, those columns are groups. Thank you very much. Yes, groups. 20 people answered correctly. Number of shells correspond to the number of shells correspond to group number, atomic number, period number, mass number. Blink of an eye. I know, Rabia. That's amazing. This group is whew. Okay, good. All right. True or false? Hydrogen is in group 1. True or false? Hydrogen is in group 1. Let's see. We spent some like good 5 minutes here. It's false. We cannot put it in group 1. It used to be in group 1, but that was stupid, right? It doesn't match the rest of the group, right? Okay. Next question. Why is helium in group 8 or 0? How come helium is in group 8 or 0? Is it the lightest gas, highly reactive, full first shell, no neutrons? Aha, look at you guys. All right. What makes noble gases unreactive? Outer shells are full, no neutrons, low mass number, high density. Excellent. Outer shells are full, usually 8, except helium is 2. Wonderful job. Isotopes have the same number of electrons only, neutrons, mass number, protons. Of course, protons. Thank you. All right. Which hydrogen isotope, this is tricky. Which hydrogen isotope has 1 proton and 1 neutron? Focus. Focus. Do not rush this. Which hydrogen isotope has 1 proton and 1 neutron? Tritium, protium, hydrogen 3, or deuterium? Yes, Noon. 9 people rushed this question. I think 9 people got it wrong. Yeah, 1 proton and 1 neutron. So 1 and 1, which makes the mass 2, which makes it deuterium. Yes, deuterium. Excellent. See, a lot of people rushed this one, which will change my chart completely. Look at this. The chart is like all over the place now. But guys, do not worry about the chart. We're having fun, right? Double points in a mass spectrometer. Lighter ions will not deflect at all, deflect more, deflect less, move slower. Lighter ions. The 60-kilogram guy, the fit guy. Deflect more or less? Deflect more. Thank you. All right. There's another spectrometer question. What increases ion deflection? What makes the ion deflection more? Is it greater mass, heavier mass, lower charge, greater charge, no charge? It's okay, Maryam Mohsen. We're learning. This is fun, right? Didn't I tell you enjoy the class? Okay, more ion deflection. Yes, greater charge. Excellent. Okay, 3 more questions. Main purpose of mass spectrometer. What is the purpose? Produce cathode rays. Boring. We've already done that years ago. Determine the atomic masses. Measure electrons. Who can measure electrons? Count protons. Who cares? Of course, it's to measure the masses, right? And it's going to give you peaks for the masses. Okay, all right. Next question. In detection at the very end, the detection stage of mass spectrometer, the ions accelerate, the ions separated, the ions strike a detector, the ions are deflected by a field. Yeah, this was hard. I mean, because it's new, right? Yeah, this is the AS stuff. Your internet lagged. It's okay. It's okay. Oh, Mariam, I'm sorry. It's okay, Mariam. I mean, it happens a lot, but we're having fun. Okay, so the ions strike the detector. This is the last stage. This is the detection stage. All right? Okay, guys, we're learning. All right? Okay, last question. If isotopes have the same charge, but different masses, different heaviness, the heavier one deflects less, or the heavier one deflects more, both deflect equally, or they cannot be separated. Excellent job, guys. Look at you. Heavier ones deflect less. You know, I'm confident you guys learned a lot in this lesson. We are done. I'm happy to take questions. If you want to open the mic, ask questions. I have one question here on the... Okay, Dua, wonderful job. Mazen, wonderful job. Menna, wonderful job. You guys are doing amazing. And then we also have Fatima and Dua, the other Dua, here on the Kahoot list. But guys, what, Omar? Guys, I do not care about what Kahoot says. I know you learned a lot today. I've been watching your answers. I read every single answer, I promise. I saw how well you performed today. So I really, really love your participation today. Thank you so much. Any questions? Did you guys get a chance to watch my 9-minute video orientation about AS Edexcel? Did you guys get a chance? Oh, Judy, do not worry about the Kahoot at all, because I mean it's a game and we're just having fun. Okay, we have 2 hands raised. Dua, we have 2 hands raised. My question for you is, what do you think? Because you're the only one who attended Cambridge and Edexcel.
Well, to be honest, both of them like they shared the same syllabus, but I think, in my opinion, I can say Cambridge was way more direct and easier than Edexcel.
Sounds good. Sounds good. I think both are really easy. Rines, you have a question? Rines Salah.
Yes, actually. For just let me check.
Take your time. We can take other questions by the time you check.
Yes. No, I'm ready now.
You're ready. Yes, go
Is
ahead.
it possible? Yeah. Is it possible to take units, all the 3 units in June?
To take all 3 units in June? Absolutely.
Yeah.
Absolutely. Totally fine.
Also,
yep.
I didn't understand the point of the purpose of the proton in the first or second slide.
The purpose of the proton. Okay. So the protons are positively charged and heavy, right? And what they're doing, did you guys, you know that positive attracts negative, right?
Yeah.
And so the protons are simply attracting those electrons, right? So they're
Yes.
keeping the electrons in the atom. If there was no protons, there's not going to be electrons. That's it. It's too simple to a point where you feel like, what is she talking about? Right? It's
Yeah.
just simply attracting all the electrons around it.
I didn't specifically understand the control losing and gaining the electrons.
Oh, okay. So this is a whole lesson that we took in the O level last year, and it was something called formation of ions. So that was a whole lesson. Actually, I think Jenna also mentioned this question. So let me ask you a question. Here is lithium, Rines. Okay. When did you take your O level? This 2025?
Yeah, this 2025.
Okay, so your results will be tomorrow?
Yeah.
I hope you do well. Okay.
Thank
So
you.
let's say you have lithium. And what is the electronic configuration of lithium?
It's 2 and 1.
2 and 1. All right. And let's say this is potassium. What's the electronic configuration of potassium?
2, 8, and 8, and 1.
2, 8, 8. Everyone pay attention. This is important. We had a full lesson last year about this. And this is 2 and 1. Okay. What do lithium and potassium want to do? What's their goal?
They're going to lose electrons.
Yes, they both want to lose an electron. Which electron? This one, right? The outer one.
Yes.
So they both want to get rid of this electron. Hey, go out, leave. These two electrons want to leave. Which one is easier to leave, Rines?
The lithium. Actually, no. The potassium, because
The potassium is
way
easier.
farther away.
Why? Yeah, because
farther
it's so
away.
far. Exactly, it's far. It is far from the protons. The protons is trying to control and attract this outer electron, but it's not very successful. So it leaves quickly.
Mhm.
Did you get it now?
Yeah, thank you.
And so because the protons here are far, it cannot really control the attraction of the electron. So the electron leaves quickly. Okay. We had a whole lesson. And guys, do not worry. In the AS, I will put for you some O-level review recordings for you to kind of refresh your memory, because some of you took the O-level in 25, some of you took it in 24. And so, yeah. Rines, any other questions?
No, thank you.
All right. Roseanne.
Hi, Miss.
Hello, Roseanne.
Hi, Miss. Miss, I have three questions.
Yes.
Firstly, okay, before the first two, you know your recordings, right? Why did you record them in Arabic instead of English? The
I
1 hour.
have So I have the classified videos in English. Okay. The
Yeah.
pre-recorded videos,
It's
just be,
recorded in Arabic.
just guys, please be patient with me. Okay. Just
Yeah,
be,
it's fine. I'm just asking. So it's fine.
yeah, I mean, yeah.
Yeah.
Um,
Okay, two things. Firstly, the electronic configuration, the SP thing. Why did we not take it today since it's an AS? It's in 1.1.
Friday. No,
Why
that's
didn't we take
1.2. That's
this?
1.2. We will take it Friday. Yep. In just 3 days. Like, yeah. In Friday, we will take that weird new thing.
Mhm.
And I want
No,
you
I
guys to
remember.
all be focused. Okay.
This another last thing. Okay, so I don't remember if you said it before, I think last year, but like the protons and the nucleus and the electrons basically orbiting it. Why don't they attract like and join together? Join up
Oh, that's a
together.
beautiful question. Like, why don't the electrons
Mhm.
collapse?
Why don't they become a neutron?
Yes, yes. Okay, so there's something about the energy of the electron that's keeping it outside and not just collapse into the proton. The way they're energetic and moving, they have enough energy to actually move around the nucleus and not just collapse. Question, totally physicsy question.
Yeah. So their kinetic energy basically, or
Yes,
like
it's because of exactly.
oh, so they orbit like planets, basically? Do they?
So not exactly like planets. Not exactly like planets. They make a cloud, so not exactly orbiting in a certain orbit. Yeah, but that's a good question.
Thank you.
You're welcome, Yahya. Yahya.
Yes. Hi. Miss
Hello.
يعني I have two questions, okay? The first one, هو when will we finish like Unit 1 and Unit 2?
We will finish Unit 1 December 5, and you can actually take the January exam if you want, or you can just take it in June. Unit 2 will be done early March and Unit 3, and you can take the exam in June. So you can take everything in June if you want, or you can take Unit 1 by January, take the Unit 1 exam, January exam, and take the Unit 2 and 3 in June exam.
But like I wanted to take Unit 1 and Unit 2 in January because
Very difficult. Too much. Too much content. Too much. Way too much.
yeah, but I already took it before. Like this is my second time taking it.
I mean, unfortunately, I mean, to give you Unit 1 and 2, we need 4 classes a week. All I got is Monday and Friday. I'm so sorry. I'm so sorry. That's really all I can do. It's a lot of content. It's a lot of work.
Yeah. I mean, like, is it doable without like for me, you know?
If you don't have many other subjects, it's doable. But your classes are gonna definitely be 4 times a week, and it's gonna be a lot of work. If you want, you can, but I mean, I don't suggest rushing things, guys. I mean, it is already a lot of work. It's already a lot of work. So squeezing it even more is too stressful. So, and life is good.
Yeah, well,
Yeah.
it's because like in the next May, I'm gonna be doing the A2 subjects, so I can't do the AS subjects with the A2 subjects.
Well, you can do them together since you already took the AS and you have an idea. The only thing is that you're repeating it again. So since you already have an idea and you took the material before, it's possible. I'm not saying it's ideal. Ideally, you want to finish 1, 2, 3 first and then do units 4, 5, 6. That's ideal. But unfortunately, I'm not offering all units 1, 2, and 3 by January. So
Mm-hmm.
you have to think about it. It's really, this is really up to you. You think about it. Yeah, because you want to do the A2, and so you're gonna have to do AS and A2 hand in hand at the same time together, same year. Um, it, that's
Yeah,
your
because
decision, Yusuf. Yeah,
it's
you
gonna be my final year in school, so I don't have any another time. Also, I have another question, Miss Lee. Like, do you teach A2?
No, not this year. Too busy. Can't do it now.
Oh,
Sorry. Yes.
okay. Thank you.
You are welcome. Dua, you have a question?
Okay, ma'am, I want to ask you about the UMS. I was watching your orientation video and you said that the papers that are hard, they would like get 110 out of 120. Like, I didn't understand, like,
So,
how
okay,
come?
the harder the exam, the higher is your score if you do well. Okay, so you do well in your exam. You guys are all doing well on the exam, right? Promise? You guys all do well in the exam because you're my students. So you do well on the exam, and it happens that the exam was really, really hard. If that's the case, your score is going to shoot up the roof. You're going to get a really high score. If the exam is easy and you make mistakes, those mistakes will cost you a lot and your score will go down. Okay, so if the exam is easy, any mistake will affect your score. Even a tiny mistake will make your score plummet. But if the exam is hard, even making some mistakes will not affect your score. You will still get a good score. Now, guys, I do not want you to think about UMS and scores and grades and any of that stuff. Guys, like with in all cases, I want you to aim for a full mark or very, very close to the full mark. Okay? I don't care about grade boundaries. That stuff, I do not look at grade boundaries. Not at all. My students are aiming for the full mark. All right? That's your goal. All right? Okay. I don't see anybody else having questions. And Jenna, I did answer your question here in this slide. Thank you so much for the 10 people who remained until the end. Dua, Razan, Dalia, Farida, Laura, Maryam, Nisreen, Noon, Nuruddin, and Omar Tamer. Thank you so much for staying until the end. Love you so much, guys. See you Friday. Make sure you join the website as quickly as possible. We already have 5 people who have already enrolled. Please enroll as soon as possible because the 1.1 homework is waiting for you to complete and finish. We already started grading everybody's work. So yes, Rabia is very happy with the attendance and the participation today. Wonderful job. Thank you so much all. Love you all. See you Friday. Thank you. Bye.